Hello everyone, my name is Omar Alexander Barra Vázquez, and this is a video for Fresnillo Congress 2022. This job is a collaboration between Universidad Veracruzana co-workers, José Román García-Martínez, Edson Eduardo Cruz Miguel, Antonio del Ángel Moreno Carbajal, and a special guest from Universidad Autónoma de Querétaro, Juvenal Rodríguez-Reséndiz. This paper is called Open Source Fuzzy Logic-Based Controller Design for Card Position in Linear Plant. Fuzzy logic arises a new mathematical concept in information processing and decision support system. Fuzzy methods gain strength when the characterization of system is complex. Otherwise, a decision-making process is carried out based on qualitative variables analyzed quantitatively. System response is produced through a set of rules the designer proposed. For this reason, fuzzy systems have become a very relevant object of study today, both in theoretical research and practical applications. Multiple controllers have been implemented using different embedded systems. Several authors have been developing fuzzy controllers using proprietary software like LabVIEW or MATLAB Toolbox. For instance, fuzzy logic-based controller for DC motor position control without load. But the controller structure is conventional. The fuzzy system takes the error and the error derivative as input. We are not taking the error and derivative error as input. This paper presents a new control structure for the control position of a card as a practical application of fuzzy logic inference in linear system. The main advantage of this methodology are the reduced number of sensors since only one encoder is required. The mathematical model is not necessary for controller design. The algorithm is developed on non-proprietary platform so that it can be easily migrated to other programming languages. For controller development, 2 linguistic variables and 49 rules were considered. However, 7 linguistic values have been deemed to describe the position of linear system from right to left. MFL give the farthest value to left and the most outlying value to the right by MFR as described in the nomenclature table. In this table we have labels. Very small, medium small are the labels for encoder, and desired very small, desired medium small are the set point of the system. Range of linguistic values can consult in this table. Membership function of fuzzy system are given by triangular membership function and trapezoidal membership function of fuzzy sets. The control signal have been prepared to 8-bit pulse width modulation and divide into outputs. The first output controls the clockwise rotation, while the second contains the anti-clockwise rotation of the system. Figure 2 displays the distribution of linguistic values along the rail. 5 triangular and 2 trapezoidal membership functions were used to characterize the movement of the card. It is essential to mention that if the linguistic values are increased, the cardinality of linguistic rule increases too. Figure 3 shows the schematic diagram of controller to be implemented on embedded system. The encoder counts are converted to centimeters and represent the actual position, which is the input of the fuzzification process for the first linguistic variable. The position reference value is proposed for the user to move the card and is processed by the fuzzifier of the set point linguistic variable. The integral of error is added to the system control signal to improve the response of the motor to low voltage and correct the steady error. The singleton membership function is used in this paper to reduce the computational cost, since it is about a real-time application where the control signal is generated each 10 milliseconds. Furthermore, 7 linguistic values were proposed for the diffusification stage, as shown in the nomenclature table. This section presents the behavior of controller implemented over the linear plant. where F labels display the weightless results and L labels show off the linear plant load with 20 pounds. As shown in Figure 5 and Figure 6, the waveform varies slightly. The error tends to 0 in both cases. The loaded plant presents an overshoot of 70% and increase to 18% with load. Figure 7 depicts the performance of the controller to a step signal of 35 cm. The control signal condition is limited to 24 volts of DC. F control signal present the weighted response and L control signal show the loaded system. The two signals respond similarly using the same amount of voltage at the beginning of the operation. According to this result, it is concluded that the controller works well even with load. Conclusion. In this paper, a new control structure based on fuzzy logic is presented to control the position of a card on a linear platform. The fuzzy system has two linguistic variables as input, the set point and the current position, which are mutually related, generating 49 rules for its operation. Furthermore, the error integral is used to reduce the steady-state error. The control algorithm is embedded in an ATmega 2560, using a sample time of 10 milliseconds. The experimental result showed the performance of the control system when the car moves freely over the rail and when a load of 20 pounds is added. The first tests were carried out with the car unloaded and present an overshoot of 70% and a settling time of 2.9 seconds. On the other hand, when the load is added to the system, the overshoot reached 80% and a settling time of 2.92 seconds. These results make it possible to conclude that the controller is robust and maintains its behavior even when the system is loaded. Thanks for watching this video. This was the presentation for Academia Journal Congress Forjando el Desarrollo Científico y Tecnológico a Nivel Internacional.